Hello everyone, this is the first lesson recording for IM2 Distance Learning Week 5. We are tackling surface area of 3D shapes. So to begin, can you name the solids here? Which ones would you group together? As usual, we started with some warm-up problems, and these similar problems will be on the quiz. So please do this now, pause the video, and the answers will be shared in a little while. Few announcements. Next week's schedule is slightly different because of the Memorial Day weekend. So what I am going to do is I am going to post the lesson recording and the homework on Monday. So no, you do not attend the class on Monday, but it will be valuable for you. Why am I doing that? Because currently it's scheduled for Friday. So if you meet on Friday and we go through the lesson, the homework is going to be due on following Monday. So it does not leave you with much time, and that is the reason I am doing this. Of course, you are welcome to just join the class on Friday here and do the quiz and whatever else. However, if you have watched the video from the lesson recording, then you can just turn up for the last 10 minutes to take the weekly quiz. But you must not forget, okay? It's up to you to remember. And if you're a senior, next week is your last week of math, and congratulations. In the final schedule, you will have finals for IM2 on Monday from 1 to 2, and Tuesday from 1 to 2 if you're from 5th period. On the finals week, we will meet for the weekly quiz, so it's not really a final, and plus optional quiz. Optional quiz is, I am just going to give you a couple of extra problems that's going to be very similar to the quizzes that you've already had. It will just be, I'll just randomly pick one out of the 5 quizzes that we've already had, and its score, if higher, will replace your lowest or the missing quiz from the distance learning period. So it's an opportunity to raise your distance learning grade. Okay, let's go through the warm-up problem answers. So if you look at this graph, where is the center? Center is 1, 2. So that means h is 1 and k is 2. So notice that there is a negative sign built in, and the radius is 2, so it's going to be is equal to 4. So x minus 1 all squared plus y minus 2 all squared is equal to 4. Number 2, the center is 0, 2, so it's going to be x minus 0, which just becomes x squared, and y minus 2, which just becomes y plus 2 all squared is equal to 16 because the radius is 4 units. Then we were supposed to identify center, radius, and then sketch the graph. Here we go. The center is 3, 0, and the radius is square root of 9, which is 3. So I start off with center and go 3 to the right, above, to the left, and below. Mark my 4 points and then draw a circle joining those 4 points. Similarly, the center here is -3, 1. -3, 1 is my center. Mark my center here. What is the radius? It's square root of 12. So you're going to have to use the calculator to find its value of square root of 12, which works out to be a little over 3, close to 3.5. So I am going to mark about 3.5 to the left, to the right, above, to the left, and below, and then again join those points together. Okay, let's get on with the actual lesson now. So what do we call this? Well, the first one, we call this cylinder, cone, rectangular prism, pyramid, pentagonal pyramid, regular dodecagon, and cone, hexagonal prism, and rectangular prism, and sphere, elliptical cylinder, and torus. How many were you able to come up with the names. Okay, when it comes to pyramids, okay, how we name them is we look at the base shape. This is rectangle in the base shape. So we call this rectangular pyramid. The base shape of this pyramid, is pentagon, and it is in the pyramid shape. It all points to joins at one point. Okay, and when it comes to prisms, you need to be you need to be looking at the base shape. Base shapes that are parallel, and you name from there. We'll go into that a little bit more in detail. So polyhedron, it's a 3D shapes with flat polygonal faces, straight edges, and sharp corners or vertices. Okay, let me say that again. The definition of polyhedron, or plural for polyhedron, is polyhedra. It's a 3D shape or solid with flat polygonal faces, so it has to be flat. It can't be curved. And straight edges. So edges are where two faces meet. They form a line, and straight edges, it cannot be curved, and sharp corners, so the vertices have to be sharp. Okay, so here we go. So we have a face, and that's a vertex because the three edges meet right there. This is an edge because the two faces meet at the edge. Okay. Alright, so then which of these are polyhedron? Well, this is a regular dodecahedron. This is 1, 2, 3, 4, 5, and 6 times 2, so 12-sided shape. Okay, and that is a polyhedron. Any other polyhedrons? Pentagonal pyramid is also a polyhedron, and rectangular pyramid, and hexagonal prism, and rectangular cuboid, or rectangular prism or cuboid, sometimes it's called. Okay, they are all polyhedron. The others are not polyhedron. Why? Because the edges are not straight, and even the bases are not polygons. Okay. All right, so special polyhedron category. So we put that into prism category or pyramid. So prism is two parallel bases. They have two parallel bases, so you can see the two bases here with multiple parallelogram faces. So the faces, the other faces are many, sometimes just three or more. In this case we have 5, but the faces are all parallelogram. And then pyramid, what's special about pyramid? It has a base and then multiple triangular faces. The faces are always going to be triangular. Okay, does not matter which pyramid it is, it's always going to be triangular faces. Okay, let's think about this. Okay, so two parallel bases, multiple parallelogram faces. That was the definition for prism. Why not say the faces are rectangles? Okay, if you see, look at this. This looks like a rectangle, that looks like a rectangle, and the base looks like a rectangle to me. It does not look like a rectangle to me right now just because it's a 3D diagram, but the faces itself are all rectangles. Why don't we call it rectangles? Why do we call it parallelogram? Because this is also a prism, and we call this oblique prism. See, the definition, it has to be the two bases have to be parallel to each other. It does not say it needs to be right on top of each other. It needs to be parallel to each other, and it needs to have multiple parallelogram faces. So this will be an oblique prism, and while as we call this the right prism. And similarly, pyramid, we have this pyramid. You have one base and multiple triangle faces. Okay, and this, where it's just slanted pyramid, we call that oblique pyramid, while as the ones that look like symmetrical and it's upright, we call that right pyramids. So what's special about triangle faces of right pyramids? Right pyramids, just look at this. See if you can see anything special about these right pyramid faces. Okay, must be isosceles triangles. Okay, so this side and this side needs to be equal in length. This side and this side has to be equal in length, and this side has to be equal in length. Okay, let's compare. But for now, we will work with right pyramid and right prism only. And pyramid triangle faces are isosceles and prism faces are rectangle. So for now, we're just going to be focusing on that. We'll only work with right pyramid and right prism. So we are not going to go there. Okay, so finding the surface area. I'm going to pause here, and the recording will be continuing in the second video.